Hello and welcome to this week's episode of Coffee with Thorben. I hope you had a great week. Mine was definitely busy with a talk at the Jug in Bordeaux, customer workshop over 2 days, and a bunch of other things. But it's my pleasure to be live again this Friday and to talk about enums, and especially enum mappings with Hibernate. There are, of course, several standard features provided, especially by the JPA specification, that make working with enums pretty basic and standard feature. But there's a lot more you can do, and these are the things I want to focus on in the first part of today's stream. Then we will take a look at the question of the week that this time I got from a recent YouTube video of mine where someone asked about nesting constructor expressions in queries, which is often asked and, from my point of view, really interesting topic. And then we end the whole thing with a Q&A session. So if you have any questions about any Java persistence related topic or something else you want to ask me, then make sure to stick around for the second half of today's stream, where we then have the open Q&A session. Okay, so let's get into the IDE and talk about enums. So here it is. If you have any questions about the things that I show you now, then of course feel free to ask. Ask in the chat while I'm showing that, and then I will make sure to dive deeper into the specific topics. So here we have a standard enum declaration in Java. Just a rating enum with the values 1, 2, 3, 4, 5. And here's a review entity. And as always, we are in the scope of an online bookstore. One of the examples that I use quite often here on the stream and in my videos. And as you know from all the online stores, there is a way to review a book or any other product and to rate it on a scale of 1 to 5 stars. And that's what this rating enum does. It stores the rating from 1 to 5 stars. So in our review entity, we can just declare an attribute of type rating and annotate it with enumerated, and then Hibernate will take care of the rest. Let me quickly double check that I set up the persistence XML correctly. Yeah, Hibernate is generating our table model, so we can simply run this test case in which we create a new review entity with a rating value persisted in the database, and then a second part use the rating to query the review from the database. But let's take a look at the persist operation first. You can see that up here at insert SQL statement, like we would write it ourselves, the rating is the third last attribute or bind parameter. And if you look down here, then you see that we store the value 0 in it as an integer. So what's happening there? Well, I persisted the rating value 1. And in my review entity, I just annotated my rating attribute with enumerated. And that means that Hibernate uses the default enum mapping as it's defined in the JPQL specification. And that uses the ordinal value of the enum. So a few of you now might ask, what the heck is the ordinal value of an enum? Well, it's the position in the enum definition. So the first one is the one that we used in our test case. And this is a 0-based index. So that one gets the ordinal value 0, that one the ordinal value 1, 2, 3, and 4. Which is something that gets quite confusing if you look at your database during a service incident in the middle of the night. So in a few minutes, I will show you an alternative way to map the rating value to a numeric value. But for now, let's just stick to the standard ordinal value. You could get the same result by annotating your attribute with enumerated and setting the enum type to ordinal. Then Hibernate again persists the ordinal value as the enum value and uses it in the query and to pass the query results, and then always maps that to the enum value and back to the ordinal value. So as you can see here, again, value 0. We can now use the rating also in the query as a query parameter. And if we do that, then Hibernate applies the same mapping there as well. So we see here that it's binding parameter, so an input parameter for the query. It's of type integer and it has the values 0. And if we get it back, then Hibernate already applies the mapping here and tells us, yeah, I got an integer from the database, but I know it's a rating value, so I already converted it to the rating value 1. So this is the standard default mapping, which has the benefit that it's pretty small and efficient on the database level. I mean, it's just a one-digit number. But it also has a few downsides. Let's say we would want to extend this enum and say, well, let's allow the user to give a product 0 stars. So they totally hated it and decide, okay, that's not even 1 star. Then you would probably add that in the beginning as the first parameter, because well, that's just how numbers work, right? You count from 0 to 5. So why not put 0 in the front? Well, the downside here is that this changes the ordinal value of each and every existing enum value. So now this one gets the ordinal value 0. This one gets the ordinal value 1, which previously was 0, and we probably have several thousand database records that still have the value 0 persisted, which in the past meant a rating of 1, and so on. So we, by accident, changed the ordinal value of all rating values, and we would now need to adjust our database and update all of the records. That's pretty unfortunate. The same happens if we, for some reason, decide to remove a value somewhere in the middle. Then this one no longer gets mapped to 3. It would now get the ordinal value 2. So I think you get the issue there. Ordinal mappings are simple and efficient, but refactoring them really sucks. That's an error-prone task, and you need to be really careful about that. Well, we don't need to store the ordinal value. We can take another approach. The JPA specification also allows us to map the enum to a string. So let's do that. And let's run the same test case again. Okay, so what do we see here? We have the same insert statement as before. The third last one was rating, and that one is this line here. So now we are storing a voucher with the string 1. And of course, we can also use it in our queries as a bind parameter. You can see that here, and we can read it from the database. So the only difference there is that we now persist it as the value as a string instead of the ordinal value. So let's take a quick look at the database. Here you can see there, now we have the string 1 stored in our database, which from a refactoring point of view is of course better. I mean, now we have the benefit that we clearly see in the database what we stored there, and we can add and remove values from our enum without breaking anything, because the string representation of the existing values is still the same. But let's say you would decide to change the string here. Let's say that now is 1 star. 1 star, 2 star, 3 star, 4 star, 5 star. That would of course break the, no, it wouldn't break the mapping to the database, but it would cause problems with all existing records, because now Hibernate would try to write 1 star to the database, and it would expect that it gets back 1 star, 2 star, 3 star, 4 star, or 5 star, and not just 1, 2, 3, and so on. So we have a solution that is better from a refactoring point of view, but still not great. We just reduced the risk of side effects, and it's now more obvious that we might mess something up if we change it. Another downside of the string-based mapping is that we now have a rather huge representation in the database. So depending on the length of the enum value, that might actually take up quite some memory in the database, which can also be an issue. Yeah, let me quickly check the chat. Yeah, if you have any questions about the thing that I talked about so far, please feel free to ask in the chat. While I'm waiting, if there are any questions, I would like to welcome Petru, Ado, George, Abi, and Zibi in the chat. Thanks for joining. And yeah, let's now take a look at an alternative. So far we just looked at JPA's standard mappings. Hi, Francis. And the thing that's missing in all of these is real control over the mapping to the database values. Well, we just apply the standard stuff, which either takes the ordinal value, which was the position, or the string representation of the email. And don't get me wrong, that's okay for standard use cases. But if you want to have a little bit more, then you need to spend a little bit more effort. You could, for example, provide your own converter or your own mapping. So what I did here is I implemented JPA's attribute converter. The attribute converter is a pretty easy way to map from a Java type to a database representation and back. And based on the JPA specification, that should work between all Java types and all types supported by the JDBC driver. Unfortunately, with Hibernate, right now, that only works with between all Java types and all types that Hibernate knows how to persist in the database. So you can't use it with a proprietary, a database proprietary data type like a PostgreSQL enum type, for example. That unfortunately doesn't work. But for that, I have a different approach that I will show you after this attribute converter. Hi, Ali. Great to have you here. Hope you had a great week. So to implement an attribute converter, we need to implement the attribute converter interface. And this is typed here with the type that we want to use on our JPA entity and the type that we want to persist in the database. And this interface is pretty simple. We need a convert to database column method, and we need a convert to entity attribute method. And well, the names of these methods tell you pretty clearly what they are doing, right? So you call the convert to database column method with a rating enum in this case. You should then double check that it is null. If it's null, we just set the database column or the database field to null. And if it's not null, then we can use it in a switch clause and well, map the rating value 1 to the number 1, 2, 3, 4, 5, and so on, So here we can define the mapping, and in most cases, it's a pretty basic and straightforward mapping. The interesting part is that we now have full control over this. We could add an enum value 0 to the rating enum, and the only thing we would need to do is we would need to add a case block here, and there's no need to convert anything in the database. If we remove something from our enum, then we just we could then just remove the corresponding block from the converter itself as well, but we basically wouldn't even need to do that. I mean, that's then just a part that doesn't get called because we no longer have that enum value. You see, we have full flexibility here, and we can work around our changes that we did on the enum to keep the mapping in the database stable. And well, the way back is the same. If we get the convert to entity attribute method, if that one gets called with the value that was stored in the database, then we just map it to the corresponding enum value. And if we decide to rename that value here, then well, our tooling will automatically rename that here in our converter, and we are good to go. So nothing to worry about there. But if you implement an attribute converter, you also need to annotate it with the converter annotation to tell Hibernate that this is an attribute converter that you want to use in your application. And then you need to decide if you want to set auto apply to true or false. Here I've set it to false to show you how that thing works. In general, I would say true is probably the better approach for this kind of converter, because auto apply defines if Hibernate shall apply this converter on each and every entity attribute of that type. Well, and we implemented an attribute converter for the rating enum, so we would most likely want to apply that on each and every rating enum. So we could easily set that to true, and we are good. We don't need to do anything else. When we set it to false, as I did here in the beginning, then we need another convert annotation on our enum attribute that tells Hibernate to apply the rating converter class and use it for the rating enum. When you're doing that, please make sure that you remove the enumerated annotation from that attribute. Based on the JPA specification, you're not allowed to use an attribute converter on an attribute annotated with enumerated. You can use it on an enum, you just can't annotate it with enumerated. And that makes total sense because the enumerated annotation defines a mapping for that attribute, and the attribute converter does that as well. So that would be a pretty confusing mapping, and we would always be wondering which of these two annotations is actually active. So better remove it. Because of that, you need to remove it, and then Hibernate just applies the rating converter here. Yeah, see more people joining the chat. Welcome, Ali and Kenny. Great to have you. Okay, so this part is still the same as before. We have the insert statement with the rating. What we now see is that we have here a log message from our rating converter. That is the one that I wrote down here in the convert to database column method. And that tells us that we got a rating enum with value 1. It would have the ordinal value of 0, and we mapped it to 1. And you can see here that we persisted 1 in the database. And right down here, the same mapping was applied for the review bind parameter in the query. So this is for the bind parameter. And then the inverse operation was applied to the result set that we got from the database, where Hibernate got the value 1, called the attribute converter with that, and that one converted it to the enum value 1. Okay, so far so good. So this is all JPA standard features with the standard attribute converter or the enumerated mapping that we had before. Unfortunately, all of them don't support the mapping of proprietary enum columns in database. So PostgreSQL, for example, supports an enum data type. So let me drop the review table real quick. So there we dropped it. And then here I have a create table statement that uses the rating enum type, which, can I find where I created that? No, unfortunately not. So the rating enum type is a PostgreSQL specific enum type that accepts the values. Damn, it's gone. Okay, let's get into the IDE and get the definition from there. So here I have everything we need. So let's copy the create type for the enum rating. You can see we created an enum with the values 1, 2, 3, 4, 5. And then I use it in my table definition. So let's go here and run that again. Rating enum already exists. Okay, that was what I wanted to see before. Now we are good. Let's refresh that here and take a look at the database table. Then we can see here that we we can see here that we have a rating enum database column. So let's get back into the IDE. Make sure that Hibernate doesn't drop and recreate that table using its own statements. And now we can start talking about supporting custom or proprietary enums. So unfortunately, as I said before, the attribute converter doesn't support database-specific enum data types, at least not with Hibernate. But what you can do is you can write your own type. And that is actually pretty simple with Hibernate, because Hibernate has the enum type class, which it uses to map enums, and you can simply extend that, and then you just need to write this one method that you can see here. So you just need to write the niceSafe set method, and in that you set the attribute as the type other, JDBC type other. So let's quickly go back to the enum. Let me quickly change that back to enum type string and no custom type, so that you can see that it doesn't work without the custom enum type. Now run the test case. We should see an error message that tells us that the data type doesn't match. That is, error column rating is of type rating enum, which is the one we just created, but expression is of type character varying. Yeah, sure, because we said that we wanted to use the enum type string as the mapping, right? So let's then activate the enum type PostgreSQL, which is the one we just looked at, and run the same test case again. So now Hibernate should use our custom enum type, which sets the parameter as type other on the statement. Yeah, and you can see the test finish without an error. Here's the rating, and that one is the only one we don't see here in the bind parameter listing. And down here, we extracted the rating as a varchar, and it's the value 1. So let's go to the database and check that it actually contains what we are expecting. So here it is. Now we have a column of type rating enum, and it contains the value 1. So now we are using the custom data type that we wrote here with just a few lines of code. We can benefit from all the Enum specific features that our database provides. And well, you can type the Enum type here with the specific kind of Enum you want to persist. But to be honest, I usually just have this in my project that then works with all enums. And the only thing you need to do is annotate the type here or use a package info where you define a type def, and then you could just use the name that you defined there to reference the type definition, and Hibernate then knows that it has to call the enum type PostgreSQL. Okay, let me quickly look at the chat. Yeah, hi Anthony, hi Chetan. And Chetan asked, can we use this converter on ID column? You're probably asking about where's my attribute converter? This one here. Unfortunately not. You can't use attribute converters on ID columns, on columns annotated with enumerated or with temporal. For all others, you can do that. To be honest, I haven't tried it, I think. I'm not sure if I ever used it, but you should be able to use the enum type that we defined here as part of your primary key. That would be something that you could try. Yeah, let's give that a try real quick. So let's make that the primary key, and does that work? Well, that now doesn't match our database definition. No, that would require a bigger refactoring here in the test case. So let's not do that for now. If you want to give it a try, then use here such an enum type and not the attribute converter. As I said, attribute converters are not supported for primary key attributes. Yeah, the enum type should work. Okay. Then let's quickly talk about the upcoming workshops. So workshops. If you enjoyed this part, you can get much more of that in one of my live workshops. They're usually 2 to 3 days long. The next one will take place at the 20th of April. Online, of course, in the current pandemic, so no traveling required. You can join it from the comfort of your home or office. In April, we will talk about Hibernate performance optimization. So how do you find performance issues? How do you avoid them in your mappings? How do you fix them for read operations? How do you improve the performance of write operations, and so on? In June, I will run my new Spring Data JPA workshop. There will be an online course for that up for sale in probably a few days. We are currently working on that course. It will go live in the next probably 2 months, 1 to 2 months. We're currently working hard on that. So I will keep you updated there. Then we have in September a workshop about microservices and how to share data between them, how to implement the communication between them, how to keep your services independent while you're sharing data with them, and stuff like that. And then at the end of November, beginning of December, we have the Advanced Hibernate workshop. And well, if you don't want to join an open workshop, but are looking for something for your entire team, then make sure to take a look at the customized online workshops. There we can then plan and schedule a custom workshop specifically for the needs of your team. Okay, If you want to find out more about that, you can see the link at the bottom of the screen, thorbenjansen.com/workshops. Yeah. Then all about now. Let's take a look at the weekly recap. So what did happen this week? We had basically 3 things this week in addition to this live stream. So there was the blog post on Tuesday in which I had a look at the migration of a monolithic persistence layer to a microservice persistence layer, especially on the part of how do you split your monolithic persistence layer into multiple independent persistence layers for microservices. And there are a few things that you need to keep in mind while doing that to avoid common issues that just create a tight coupling between your services and let you end up with basically a distributed monolith, which would be the worst parts of both worlds. So in this post, I quickly described my approach to identify independent modules. Yeah, that is the main part of my approach of how to split microservices out of a monolith. In my experience, it's the best thing to start with modules. So modularize your service, your monolith first. Solve most of the issues while you are still in the comfortable in the comfortable monolith, where you don't have to worry about separated deployments, where you don't have to worry about network communication or these kind of things. So split that thing up first into different modules, then get rid of queries and associations between your modules, because that is no longer possible in a microservice persistence layer. And I give a few suggestions here on how to handle that. Then start working on the write operations, if there are any that affect more than one microservice, which unfortunately happens every now and then. And then comes the easy step. Just split up the modules into separate services. If you did step 1, 2, and 3 well, then step 4 is a piece of cake. Just copy the code into separate folders, add a little bit of deployment and build tuning, and you're done. Then we had a video up on YouTube yesterday about the mapping of collections. The most common and best known approach there is for sure the mapping as an association, as a to one or to many association. But you can do more. You can also use element collections, or you can use custom types that then store that as one basic attribute in your database, and I explain all of that in that video. Or if you prefer reading, then you can click on the video description here, and there you find a link to the post, and of course additional links that are mentioned in the video. Yeah, and that reminds me that we had something to celebrate this week. We reached 25,000 subscribers on YouTube. That's incredible. In the beginning, I thought, well, okay, maybe we get to a few thousand. We got a few subscribers every video, and now we are at 25,000. That's really crazy. So thanks to everyone who already is a subscriber. And yeah, I hope I can keep creating good and useful videos for you. You can find all the links that I mentioned on this stream today on thorbenjansen.com/live. There you find a quick introduction to the Enum part that we talked about in the beginning with more links, and you can see here links to the content and so on. Okay, then let's get to the question of the week. The question of the week comes from a recent YouTube video. So I have no clue how to pronounce the name. Ajay, maybe. I hope I didn't butcher that name too badly. So that was a question about DTO projections. And yeah, he asked, do these constructor expressions support nested DTO projections, like objects with collections of objects? And no, unfortunately not. There is no support for nested DTOs. The only thing you can do is you can call the constructor of your class with all the parameters that you need to call other constructors. But then, well, let's get into the IDE and take a look at that. That's probably easier to explain there. So here we have a constructor expression. And there constructor expression always start with the keyword new, and then we have the fully qualified class name that we want to instantiate and a list of parameter that we want to provide to their constructor call. And here we could now, for example, do add more attributes of the, let's say, of the publisher. And in the book value constructor, we could then instantiate a publisher value. So here we could say new publisher value, and so on. That supports some form of nesting, but it's not the form of nesting that that was asked about in the question. In the question, the idea was to have a more complex data structure, to have a list of other objects, of other DTO objects. And unfortunately, that's not supported. And I don't expect that that will change at any point soon, because the constructor expression that we have here gets applied to each and every record in the result set. And that result set is provided by the database, of course. And the thing there is that if you have, let's say you have an author with books, then, and one author has written multiple books. If you then select information from the author and from the book, then the database multiplies the result. So you get the author as many times as she has written books. And you would get author 1 with all her information, and then all information of her first book, and then all information of author 1 with all information of the second book. That's just how SQL and databases work. And well, on this result set, we now apply a constructor expression. So Hibernate calls a constructor via reflection and puts these return values into the constructor. There's no way that we can create a collection out of that. So yeah, that's a commonly asked question. And I would love to be able to work with lists in these constructors, but unfortunately that's not possible. So unfortunately, no, there's no good way to work with nested constructor calls in our JPA Equimemetics. Yeah, thanks to the kind words in the chat. Really appreciate that. Yeah, I think YouTube, creating videos for YouTube is, to me, a lot of fun. I really enjoy doing that. And yeah, it's great that so many people enjoy watching them and find them useful. Okay. Yeah, we reached the end of my preparation for this stream, of the prepared part and elements of our weekly Coffee with Thorben. I hope you enjoyed it so far, and I hope you brought a few questions to the Ask Me Anything section. So do you have any questions about JPA and Hibernate? Is there something we should talk about? I take a look at the chat, but I think I already answered all the questions that I saw in the chat so far. Yeah, looks like that. Okay, I will stay a little bit longer here in the stream. If you have any questions, then please ask them, and then we will talk about that. I will quickly take a look at quickly look after the video that we did from last week's talk at the Java user group in Bordeaux, and paste that to the chat as well. So if you like to take a look at yesterday's talk at the JUG in Bordeaux, then you can watch that here at the link. And the next talk will be in 3 weeks at the JUG in Switzerland. But I think, well, I need to double check, but I think that one will be in German. So yeah, but keep an eye on the on my social media channels, or join my email list if you're not already joined. Then I will announce that talk there as well. It will take place on the 9th of March. Okay. Petia posted a question in the chat, so let's take a look at that. I created an entity with a version field and a collection of other entity. How can I use this version log when adding concurrently new entities to this collection to avoid collision? Okay, let's take a look at that. So let's get into the IDE. So let's see, do I have an optimistic locking example here? Yeah, that's what I'm looking for. Optimistic lock force increment. So when you're using optimistic locking, then you add something like this here to your entity. You add usually an attribute of type int, sometimes of type short, to your entity, and annotate it with add version. And that tells Hibernate to use optimistic locking. Optimistic locking it's not really a locking, it's an automated versioning and version check algorithm that's applied. So what happens here is Hibernate manages this version number and increments it with each and every update. And when Hibernate executes an update, it checks that the version number in the database is still the same version as the record had when Hibernate read that entity. And by doing that, Hibernate can detect if someone else updated that same database record in the meantime and throw an exception. That works really well as long as you just work on one specific record, or as long as all the concurrency conflicts you want to avoid always happen on a specific database record, like on a book. But if you have a parent-child association, like we might have here with the reviews, where you say, okay, if we add a review to the book, then that should also affect the version number of the book. Or if we add another book to an author, then that should increase the version number of the author. Then this doesn't work. And it doesn't work because the locking, then if you add a new book, would only happen on the book record itself, but it wouldn't affect the author. So what you can then do is you can use optimistic force increment, and you can do that either in this way. You can call the lock method on the entity manager with optimistic force increment, or you can create a query and then set the lock mode on that query with optimistic force increment. And if we now run this test case, for example, and I hope that I have the right database up and running, let's see. Not too optimistic. Let's see, let's run that again. Yeah, that's better. Okay, so if you look at the test case here, we have a select statement that gets the book with the ID 1 and no write operations. We just set the log mode for that book. So what Hibernate does is Hibernate selects that book and Hibernate executes an update statement that increments the version number on that book. And by doing that, we can now use the book as the central place in our application or in that use case to avoid concurrent modifications of any list associated with that book. So what you could do is you could now add or remove reviews in to that book, and as long as you always use the optimistic force increment on that book, you would detect these concurrent modifications on the book record. Or maybe you have, let's say maybe you have a contract for, you have a customer account in your system, and a customer can have multiple contracts. And based on the contracts that that the customer has, you want to apply certain discounts. Let's say you have a family account for at a mobile phone provider, and depending on how many phone contracts and numbers that family has, you want to apply certain discounts. Then adding or removing contracts to that overall account would affect the discount, right? And then you would need to use optimistic locking with force increment on that account. And by doing that, you would detect concurrent modifications and could then reject the second and third concurrent modification on that account. Petia, I hope that answered your question. If not, then please let me know, and then I dive a little bit deeper into certain parts of it. But this would be the general approach. So you use you use log mode type optimistic force increment on the parent object, and you can either do that by setting the log mode on the query or by calling the log method on the entity manager. Zahari asks, is there a way to get the ID of a lazy loaded child object without loading the entire object, perhaps through a getter on the parent object? That depends on the type of association that you have. Here, with the review, for example, if this one would be lazy, if this one would be lazy, then you could still get the ID attribute on the so Sarah's question was about a one-to-one association. That's basically the same as this many-to-one association here. So it works as long as your entity maps the foreign key column. In that case, like here, Hibernate instantiates a proxy object for that book and initializes it with the primary key attribute, or the primary key value of that associated book. And as long as you don't access any other attribute, Hibernate doesn't trigger an additional query. So let's see if I can present that here on that. Yeah, okay, so we can get the book with ID 1, no, the review with ID 1, and that one is connected to the book. So if we go here, let's quickly try that. This query here gets the book with ID 1. And if we now do parent get, no, it's the wrong way around. Let's take this, go here, give that one a unique name, and we are now using the entity manager to get the review with the ID 1, and here we should be able to do get book, get ID. Book ID. So because we set the review to fetch type lazy, and we are only accessing the primary key attribute here, this one shouldn't trigger a query when we access the primary key value. Yeah, so here you can see we have the query that gets the review without the book, and we can print out the ID of the book without triggering another query. That would change as soon as we do something like get book, get title. That information isn't stored on the review table, so Hibernate has to execute another query. See here, we get the review. That one contains the FK book. So Hibernate instantiated a proxy object for that book. And we can print out the book, but as soon as we access any other attribute, Hibernate has to execute a query and get all the information from the database. In case you need the additional book information, you should then use a join fetch clause to revert that, yeah, to initialize the association. Sure, I have an example somewhere here, join fetch. So you should then do something like this and do a left join fetch from the author to the books to get the author with all associated book objects, or as in the previous example, you would join from the book to the reviews. But as long as you only need the primary key and the entity object that you got from the database maps the foreign key column, you can access that one without an additional database query. Any other questions? Okay, looks like we answered all the questions. Let me quickly check what we will be talking about next week. I created a list of topics for the next streams. Yeah, next time we will talk about utility classes provided by JPA and Hibernate. So all the small little helper classes that, or at least the most common ones that are available and that make our life as a developer so much easier. And yeah, Francis posted another question in the chat. So he asked, how do we get the equivalent functionality of common table expressions in JPQL? Can you help me with that? What do you mean by common table expression? It was a long week and I'm putting a blank right now. Oh, yeah. There is no way to do that with JPQL. If you want to use something like that, then you would need to execute a native SQL query. But with JPQL query, you are just limited to the mapped entity classes and to basic join operations and to simple selects and where expressions, but nothing more. As soon as you need more than that, you need to use a native SQL statement instead. So you would do create native query, and then you put your plain SQL statement here. And in that statement, you can do whatever your database supports. Hibernate just takes that statement, sends it to the database, and then handles the result. Okay, Suniman asks, is there any analog to Spring Data Pageable in Hibernate? Yeah, you would need to implement that yourself. So Spring Data, everything you get with Spring Data JPA can also be done with Hibernate, because Spring Data JPA provides all its functionality by using Hibernate. So it has to be there. The issue is, the question just is, how would you implement that? And with Pageable, Spring Data JPA provides great usability. It's much easier than with Hibernate, which doesn't mean that's complicated with Hibernate, but requires a little bit more code. There, query pagination. So what you can do with Hibernate is you can set the max results that you want, so maximum number of results you want to get from your query, and the first record that you want to get. That's analog to the stuff that you do in an SQL query. So let's change that to 1 to 5. So we skip the first record in the result set, and we then want to get 5 records. And let's see. Then we get a limit and an offset clause in our query. And that would mean we now have limit 1, offset 5. We would get the second until the 6th record from the result set. To get the same functionality as you have with the Pageable feature in Spring Data JPA, you now would also need to count the number of you would need to execute another query to count the overall number of records that match the where clause, and you would then need to navigate through the page result yourself. So you would need to calculate the first result based on the page that you're currently at. That's not a big deal, just a few lines of code, 2-3 lines of code, and then nothing more. Govindra asks, is there a way to use Hibernate or Panache in a non-Quarkus application? I think not. As far as I know, the Panache is based on a few features exclusively provided by Quarkus, and it's build-time code generation. And no, I'm not aware of any way to use Panache outside of Hibernate. No, outside of Quarkus. If you want to get that, you either have to use Quarkus or you need to take a look at Spring Data JPA, which is pretty similar with the feature set, right? Which provides similar features and a little bit more. Or you can take a look at Apache Data Spike. Apache Data Spike data is basically the Spring Data JPA repository feature set for CDI and Java EE environments. So they get a pretty similar feature set. That would be the two options. Yeah, if there's some interest in Panache and in Quarkus, please let me know. Maybe we can invite someone from the team to join us on a weekly stream, or maybe we can do just general live stream about Panache and the persistence support in Quarkus. Okay, any more questions? Not, then we can close the stream and start enjoying the weekend. Okay, then I want to thank you for joining today's stream. Thanks for all the questions. I hope you found it helpful. Next week, Friday at 3 p.m. CET, so same time as this week, I will be back and we will be talking about utility classes in Hibernate that, for example, allow you to get the specific entity object from a Hibernate proxy, which makes it easier to work with query hints and a few other things. And yeah, that will be part of next week's stream. Okay, thanks everyone. I wish you a great weekend. Stay healthy and see you again next week. Bye.